All right, let's dive in. In the world of AI, there's this constant race to build bigger and smarter models. But here's the catch. As these digital brains get more powerful, the cost to actually run them is getting out of control. So today, we're going to pull back the curtain on a really clever AI design that promises all that massive power, but without the crippling price tag. Let's get into it.
And really, this is the billion-dollar question, right? It's the huge challenge the entire industry is grappling with. The more capable we make these large language models, the more computing power they need, and the more money gets thrown at them. That kind of spending, it just can't last forever. So how do you break through that wall? Okay, so to really get why this new approach is such a game changer, we've got to first look at the old way of doing things and see exactly why it's starting to hit a wall.
You can think of it like this. For the longest time, if you wanted to build a taller skyscraper, you just had to make the base bigger and the whole structure heavier. In AI, that meant building one single gigantic network, this huge monolithic model, and just force-feeding it more and more data. But just like with skyscrapers, you eventually hit some serious limits, both physically and financially. You can't just keep adding floors forever. And that, in a nutshell, is the scaling problem.
Okay, but what if there was a smarter way? What if instead of one giant brain that has to know everything, you could have a whole team of specialists? Well, that's the brilliant idea behind a technique called mixture of experts. So the core idea here, and this is straight from the research, is to completely ditch that single giant model. Instead, what you do is you build an AI that's made up of lots of smaller, more focused neural networks. And these little networks are called experts. But here's the key. For any one job, you only use a few of them at a time. So how does this actually work? Well, the analogy is actually super intuitive. Think about going to a hospital. You don't talk to every single doctor, right? Of course not. You first see a general practitioner. That's our router. And they figure out what your issue is. Then they send you to just the right 2 or 3 specialists. Those are our experts. Maybe a heart specialist or a brain specialist. The AI works the exact same way. A request comes in, the router takes one look at it and says, okay, this is a job for expert number 3 and expert number 7. It then passes the job only to them. All the other experts, they just stay off, saving a huge amount of computational energy.
And this is where the magic really happens. It means you can build a model with a truly massive number of parameters, and you can think of parameters as all the little knobs and dials the AI uses to think and learn. So, a model like Mixtral 8x7b has this huge brain, making it incredibly knowledgeable. But, and this is the important part, for any single calculation, it only uses the energy and cost of a much smaller model, because only a couple of those experts are ever on at the same time. It's how you get massive scale with a cost you can actually manage.
Now, on the surface, this sounds absolutely perfect, right? You've got this committee of geniuses, each an expert in their own little domain, but that leads to a really interesting and, as it turns out, a super important question that researchers wanted to dig into. Yeah, here's the thing. We call them experts. We assume they specialize. But is that what's actually happening under the hood? Does one expert truly become a master of writing poetry while another one becomes an expert in Python code? Or are they all kind of the same, just generalists that are way more similar than we've been led to believe? This is the big mystery that the research paper we're looking at today tries to solve. All right, so what did the researchers actually find out? They decided to peek under the hood of some of these big mixture of experts models, including the famous Mixtral model, to see what was really going on inside. So to figure this out, the researchers used these things called heat maps to see how similar each pair of experts was. It's really easy to read. The brighter the yellow, the more similar 2 experts are, like they're basically clones of each other. Dark colors mean they're very different. So the big question is, what did the map look like? Well, the results were pretty surprising. Instead of seeing this diverse team of specialists, the heat maps for Mixtral showed a ton of bright yellow. That means many of its so-called experts were incredibly similar to each other. They weren't the distinct poetry expert and coding expert we might have imagined. A lot of them were basically doing the same job. So why? What's going on here? Well, the researchers think they found a pretty big clue, and it all comes down to how these models are trained. They saw that other models like DeepSeek and Grok, which were built from the ground up, showed a lot more diversity among their experts. Mixtral, on the other hand, was full of similarities, and that led them to a hypothesis. Maybe Mixtral was upcycled. Now, this is basically a shortcut. You take one single, powerful, pre-trained model, you copy it 8 times to create your 8 experts, and then you just tune them a little bit. If they all start from the exact same blueprint, it kind of makes sense. They'd all end up looking pretty similar, right? It's a faster, cheaper way to get one of these big models out the door. And this isn't just a guess. The paper's conclusion points right to it. The authors themselves say that they believe if you really want a team of diverse specialists, you have a much better shot if you train the whole thing from scratch, instead of taking that upcycling shortcut.
Okay, so what does this all mean for the future of AI? Well, it tells us we need a much more careful, much more deliberate approach to building these incredible systems.
You know, the number one takeaway from all this is pretty clear. You can't just call a part of an AI an expert and hope for the best. Real, meaningful specialization, the kind that's going to unlock even more powerful and efficient AI, that has to be engineered on purpose. For the people building these things, it creates a really important choice. Do you take a shortcut like upcycling to get a big model out there quickly and cheaply? Or do you make the massive investment of time and money to train one from scratch, hoping you'll get that genuine diversity of experts and maybe, just maybe, better performance? Bottom line, how you build these things matters a lot.
And this leaves us with a really big question for the whole field. See, the promise of mixture of experts isn't just about saving money, it's about a totally different way to build intelligence. But as this research clearly shows, getting that vision of a true team of digital specialists, well, it's not a given, it's a choice. So as we keep pushing what AI can do, the industry has to figure out which path is better, the old school brute force single giant brain, or the new art of creating a real coordinated team of experts. We don't know the answer yet. It's being figured out right now. Thanks for digging into this with me.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.